Welcome, ladies and gentlemen. My name is Maximilian von Humpel, and this is our entry to the Summer of Mathematical Exposition from 3 Blue, 1 Brown. We have decided to make this topic about the general hatred and gender gap in STEM fields. Due to our team being from all around the world, we had difficulties with scheduling, and therefore we decided to split this discussion into multiple parts. Each part is researched and explained by one of our team members, with a healthy mix of his opinions and scientific facts. I will start off now with my topic about mathematics in school and why it is a subject that is mostly hated. Enjoy.
Welcome. My name is Maximilian von Humpel, and I will share with you my thoughts on the impact of mathematics in school. It is greatly known that students either hate or love this subject. Before we start with the actual topic, I want to make sure on what side I am on. I started as a pretty isolated geek at a very young age, which developed my interest in mathematics to the point where I started to read theoretical articles about mathematics during middle school, which in my country is at age 10 to 13. I want to point this out just because I did not experience most of the following problems myself, but was present while they happened to others. For many years, students all around the globe have been arguing about the importance of mathematics in school. Sadly, the majority comes to the conclusion that the field is not worth pursuing in the future and starts to build hate against it. That leads to students who are unwilling to learn more or even try. As said in the beginning, I was in the minority of people who enjoyed mathematics and got interested very early on in real mathematics, as we call it. Over the years, I'm pretty certain that I have come across multiple different reasons for students to start hating mathematics. For our discussion, we will focus on points that were pointed out in various Reddit threads about the said topic. The lead arguments for this discussion were mathematics is useless and has no use, and teachers cannot teach it well. There are many more, but in the end they criticized pretty similar things. All arguments in general is that they can have multiple similar origins and ways to be approached. Let's first look at the statement that the subject is actually useless. If we look at the statement, we see that we have to clarify multiple things before we can actually discuss it. We have to define at what point the subject can be called useless, and then we can compare mathematics to it. At the end of the day, everyone can say for themselves if a subject is useless, but let's consider for the start that there is a general definition. From most discussion points and argumentation on Reddit, you get the image that a subject is declared as useless if it does not have a practical usage in our day-to-day life. So now we have a definition. Let's compare mathematics to it. I'm going to split this into two parts, the simple mathematics that are taught in pre-high school and the complex mathematics that are taught after high school. During preschool, you can clearly see that mathematics has its uses in our life. We need to count change, see if all ingredients fit into the pot, and so on. So here we can say mathematics is a useful subject. During high school, however, the problem starts. Mathematics becomes more and more complex until you can barely imagine it. A good example are derivatives. A teacher usually does not teach the use in our lives of derivatives, which is actually a pretty important one. A simple answer would be that you can use it in physics to go from certain measurements to the other. For example, acceleration is the first derivative of velocity with respect to time. But what about the second or third derivative? They have a similar meaning, but become harder and harder to imagine, which results in mathematics being declared as useless. Because in high school, students are at the point in their lives where they decide what to do, and this is also the point where you tend to look if you need certain subjects. And following our little proof, I came to the conclusion, that although some math is actually really useful, most of it is complex and a really theoretical subject. Now let's look at the second approach. That students don't think that the subject is not cool, and people who like the subject are always treated as geeks or outsiders. This point is fairly similar to the first one. It always looks at the subject in a way that it is not useful. But I personally think that this problem is more about the student's personality and the life choice. Because a student can say they do not like mathematics, which is a perfectly valid reason to not study it. But the main difference to the first reason is, in my opinion, that you need to spend time studying to gain interest in the field. In our early years, we rarely prefer studies of friends, and therefore geeks who decide otherwise are treated as uncool and outsiders. This leads to people not caring about the subject to be part of the bigger group and the cool people. The third reason I will confront today is also one of the lead arguments, that the school fails to teach those subjects and that it's the teacher's fault. And we have already established that students themselves cannot be interested in mathematics. But a great deal of this decision is that teachers should inspire the students to be interested and curious. This fails on many levels. One, the teacher just does not teach the meaning behind mathematics, but only the problem or answer mentality, which is at some point not the right approach, since the way to the answer is the actual interesting and engaging part. Often, teachers have a hard time to integrate really smart students with students who are a bit behind, which leads to missing foundation and therefore an awful preparation for complex mathematics in high school. Another reason can be found in a variation of different teachers over the years. Every teacher has a different approach to the problem and also chooses to teach the methods that seem to be the best in their perspective. But if you use another approach, you are often punished for not choosing theirs. This can be summarized in the mentality of punishing failures instead of embracing them and guiding students to the right path, even if that means getting them only through the class and then stop pursuing it. After all this talk, we established many problems. And even today, even nowadays, I read through math articles and think to myself, how could we motivate non-math lovers to study this kind of article? But that's actually the wrong thought, because once you are at level where you enjoy reading these articles and search for them, you already have an interest to the subject. So thank you for your attention.
Hello, I am Dhruv and I'm going to talk about dyscalculia. So, many people suffer from the misconception that maths is hard and that they are not one of the maths people. This is not true, and a lot of it stems from inefficient teaching techniques, but 3 to 7% of the population suffers from a very real pathological maths disability called dyscalculia. However, struggling with matrices or flunking calculus in college usually doesn't mean that you have dyscalculia. Dyscalculia comes from Greek and Latin and means counting badly. It is equally likely to happen to people of both genders. There is no gender gap. This condition impairs an individual's ability to learn number-related concepts, perform arithmetic operations, mental maths, simple calculation, recognize patterns. They find it hard to count, calculate taxes, and play Sudoku. Such an impairment puts them at a disadvantage in work and everyday life, and it also leaves them susceptible to other forms of mental illness. These people have better success rates in suicide attempts than in solving the Riemann hypothesis solution attempts. So this is very alarming. Dyscalculia declines into two forms. Developmental dyscalculia means that they were born with it, and acquired dyscalculia means that it's a result of a stroke or injury. Daniel Radcliffe, Steven Spielberg, Justin Timberlake, Michael Phelps are all dyscalculics. So it doesn't mean that dyscalculics can't be successful, it's that they have different talents and abilities. What they miss, their brain makes up for another ability. So finger counting is typically linked to dyscalculia, but it is not an indicator of the condition outright. Persistent finger counting, especially with easy, frequently repeated calculations, may indicate a problem. Computation errors alone are also not indicative of dyscalculia. Variety, persistence, and frequency are key in determining if dyscalculia is present. So it's hard to detect dyscalculia. While a diagnosis may be difficult to come by, treating a patient's other conditions may also alleviate their dyscalculia. So Dyscalculia is closely associated with problems in the parietal lobe that affects one's understanding of the number system. Researchers have been able to induce it in normal people. So in this study, researchers applied transcranial magnetic stimulation or TMS, a non-invasive procedure that uses magnetic fields to stimulate the nerve cells in the brain through the right parietal lobe. While the subjects were comparing quantities, they found that the stimulation briefly made it hard for the subject to tell if one quantity was bigger than the other. There is no cure for dyscalculia, but dyscalculics can learn maths, even if they may always struggle with parts of it because of their neurological differences. Therefore, early detection is key in helping children cope with dyscalculia. And for adults struggling with the disorder, a shift in attitude may be the first step in overcoming the obstacle. The goals of treatment therefore are to fill in as many gaps as possible and to develop coping mechanisms that can be used throughout life. This is typically done through special instruction, accommodations, and other interventions. Adults with dyscalculia, however, may be entitled to reasonable accommodations in their workplace under the Americans with Disabilities Act or ADA, America. So they can also commit to brushing up on math skills on their own or with the help of a trained educational psychologist. Even the most basic improvements in math skills can have long-lasting impacts on day-to-day life. Thank you.
Bonjour, I'm Julien and today I'm going to give you a little overview of the gender gap in STEM. First, I would like to give you some definitions. So I consider a scientific job every job classified as a STEM: science, technology, math and engineering. But I will also make the difference between two subcategories: the GEMP, geosciences, engineering, economics, math, computer science and physical sciences, which rely heavily on math. On the contrary to the LPS, life sciences, psychology, and social sciences, excluding economics. For short, STEM represents all sciences, GEMP represents math-heavy fields, and LPS are all the leftover jobs that don't fit in GEMP. So now, I would like you to picture a great mathematician, physicist, or computer scientist. Chances are that you have imagined a man, and if I asked you to picture a nurse, you would probably have a woman in mind. This is a pretty common stereotype resulting from our society's records of women's stigmatism. However, while looking at data, we can see that the stereotype of less women in science is not as straightforward. In fact, 51.5% of UK STEM undergraduates are women. As you can see, the gender gap has another dimension, where not only we have to cope with the GEMP fields being dominated by men, but also the LPS fields are dominated by women. For simplicity though, I will focus on the former in the next parts. The main problem with this gender gap is that it is a self-fulfilling prophecy, as many of its effects are part of its causes. The main problems are that during childhood, teachers and parents are not supportive towards girls interested in scientific topics, and children are exposed to more gender stereotypes than female role models. And the way mathematical competences are evaluated in a competitive environment is detrimental to girls, as studies suggest that they tend to perform worse than boys in stressful conditions. During adulthood, companies don't give enough attention to the male overrepresentation in their workforce and the discrimination. The effects of high expectation, low consideration behavior with very little room for failure can drive women to burnout. This is so stressful, it pushes many women to quit their job. Hence, their coworkers think they didn't like science in the first place. From my experience, My sister, who has barely entered middle school, already knew that math were hard and focused her attention on other topics. When I try to communicate my passion for math at home, I feel like talking to a wall, since I'm the only one with such passion for mathematics. On top of that, while doing competitive mathematics studies, I experienced an environment where sexist jokes were common, and I was seemingly the only one to care. Not even the roughly 20 to 25% of my classmates who were girls didn't react to them. I can't even imagine how hard it is for women to work with people like that, or because they waste so much time on coping with others' prejudiced behavior they can't focus on what really brought them to do math in the first place. Well, everything isn't so black and white. Even in gender-equal countries, women tend to perform worse than the countries on the other side of the spectrum. This is called the gender gap paradox. See for yourself on this graph. As you can see, Finland, Norway, and Sweden score high on gender gap index and low on female STEM graduates, while Algeria, Tunisia, Turkey, and the United Arab Emirates score the opposite. This phenomenon is not explained yet, but we have some hints on how this can be happening. First, it is important to note that the more gender equal the country is, the less the salary will be taken into account while choosing a job. So, in the first group, women choose their job to fulfill a passionate choice, while women in the second group follow a path to economic independence instead. The other hint is that those countries from the second group are all coming from the same region, the Middle East, where women are less victims of the glass ceiling like in most Western countries. Alright, all this seems pretty grim, but there are actually a few actions you can make to help people around you tackle this gender gap. Just like me, you can start now, documenting yourself about great female role models and share them with your friends and family. You can also discuss with them the terms of woman legitimacy in math-heavy fields and invite girls and women to try out some math and science. What women and girls need to be able to pursue scientific studies is both motivation and consideration. This is something that is easy to give once, but it's hard to make it a habit since it goes against a lot of implicit biases. Thank you. This was Julien for the Summer of Math Exposition.